So we finally made it to problem 19. There's only 2 problems left on the chapter 1 algebra review, algebra 1 final exam review. And we're looking at parabolas or quadratic functions for our last 2 problems. So we're asked to identify the characteristics of the quadratic function listed here. So what is our vertex? It says the vertex is blank and blank. And our vertex is an x comma y value. And the vertex, when we look at our graph, is the either highest or lowest point on the graph. On this one, since it opens down, we have a highest point or a maximum value for our vertex. If we look at our vertex, it is 1 unit over to the right. So that's a positive 1 for the x value. And it is 1 unit down on the y-axis. So it is a minus 1 for the y value. Now, the next part of it asks us about our axis of symmetry. And the axis of symmetry, I'm going to go ahead and draw onto this in a nice shade of light green. Our axis of symmetry is a vertical line at x equals, as you can see here, that cuts our parabola into 2 symmetric halves, which are meaning they're going to be mirror images of each other. And the line where that occurs is going to go right through here. This is our axis of symmetry. So our axis of symmetry cuts through the vertex, meaning that the x value of the axis of symmetry is equal to the x value at the vertex, which in this problem is at 1. All right, up next we have the domain. Now the domain refers to all of the values that our x can take on. And for a parabola, even though it looks like this parabola is mostly going down, as we can see it on this graph, ultimately it will extend in all directions, left and right. So we will be able to take on any x value. And when you can take on any x value, this is known as having a domain of all real numbers. Now, what about the range? Well, the range requires a little bit more thinking. Whereas for all parabolas and all quadratics, the domain is always all real numbers. The range refers to all the y values we can take on. And when I was talking about the vertex earlier, I mentioned a key word, maximum. This function has a maximum value in terms of the y right here at the vertex at y is equal to -1. And that means that all other y values must be less than that -1. So if we think about this, that means that the y values of this parabola can be anything up to and including -1. So we're going to have a y and a -1. And now we just need the appropriate inequality symbol. All the y values are going to be smaller than -1. So that means we're looking for the less than symbol. However, because the parabola is actually -1 right here, that means that our y can also be less than or equal to -1. So we combine the less than and the equal to or equal to symbol with the bar at the bottom. One thing to keep in mind is that every single parabola includes its maximum or minimum value because it actually is that value at the vertex. So it will always be or equal to. So you'll always have this bar on the bottom. It's only a matter of whether or not using the less than or the greater than symbol. If the parabola opens down, we use the less than symbol because this is a maximum that cannot be exceeded. If it opens up, we use the greater than symbol because everything will be bigger than the minimum value at the vertex. Now, the last 2 portions of this refer to the increasing and decreasing portions of the graph. So it says when x is less than 1, so 1 is right here. So when x is less than 1, we're on this side. When x is less than 1, as y increases, so as y is going up, what's going on with x? So we need to look at the left half of our graph and figure out how it's moving when y is increasing. So if we start from over here, y goes up. Y is increasing as we go up the hill. And what's happening to our x? Well, our x is approaching 1. This is the point where the x hits has the axis of symmetry. And up until that point, x is increasing. So as y increases and x is less than 1, x also increases. On the other hand, when x is greater than 1, as y increases, all right, well, let's look at this. Where x is greater than 1 is on this side. And what's going on with y? Well, in order to go up the hill, we need to start down here and go up. And as we start down here, our x value is around 3.5. And then as we start increasing, our x value gets closer and closer to 1, meaning that our x value is getting smaller or our x is decreasing. Or I should say rather decreases. The reason why I changed it to decrease is not only to match increases, but also because that was part of the pool of answers that will be provided to you on this question when you're working on it on the test. So make sure that you don't make any silly mistakes on this one. For one thing, when you're looking at the domain, it's always all real numbers. For the range, we have these inequalities, but for the range, it doesn't have anything to do with x's. It's all about y's. So that will reduce the number of answers that you'll have. The vertex, the axis symmetry, all of those just use regular numbers, and then obviously you have increasing and decreasing down here. All right, so let's go ahead and take a look at problem 20, because that's the last one on the test. Problem 20 is a little bit of a doozy. We got a lot of stuff going on here. We first need to identify the graph, and then we need to fill out a number of features of the graph. So our graph is g of x is equal to -1/3 times parenthesis x plus 3 close parenthesis squared minus 2. So this is in what's known as our vertex form. And vertex form allows us to read the vertex right out of the equation, but we do have to do a little bit of thinking. So the first thing we can look at is we need to look at the translations that are appearing here, because those are the two easiest to examine before we start thinking about the vertical stretch or shrink and whether or not we have a reflection. Now, we need to figure out where the vertex has moved, because we want to think of it moving from the origin, which is right here where the two axes intersect, and whether or not it's moving up and down, left or right. And it's always easiest to start at the up or down movement, which is this one sitting out here, because the up or down movement just tells us exactly what's going on. If it's -2, we're going down 2 units. If it's +2, we're going up 2 units. And if we look at this one, we have a -2, meaning we're going down 2 units. And if we look at this graph, and this graph, all of these moved up. The only one that moved down was this one. So by process of elimination, we get that this is the answer. That being said, you also could have used the left-right movement, which here is 3 units to the left. Now you might say, but that's 3 units in the negative direction for x. Well, unfortunately, when we're inside the parentheses here, we actually have the opposite movement to what it would appear that it seems like should be moving based upon what went on out here. So if it's plus inside here, that's actually a movement to the left. If it's a right movement, then we're going to have a minus inside our parentheses. And in addition to that, we have a -1/3 on the outside here. The negative tells us it opens down. This one opens down. And the 1/3 tells us it's wider than the parent function. This is the one that's the most difficult to tell from a graph like this. It's definitely the most difficult to tell, although you can kind of get an idea by estimating essentially from the vertex. Is the next point going to be, actually it doesn't really work on this one because the points aren't well enough defined. I was going to say you can try and use the 1/3 to say, all right, our next point should be 1/3 unit over. So down 1 and over 3, or down 1 and over a third. But it's just not quite going to work on this one. So I would try to avoid using the step rule on something like this unless it has a very clearly defined starting point, because it's really difficult to tell that this thing has moved for 1 unit over, has moved down only 1/3 of a unit. So you got to be careful of that. All right, now we need to fill out some information for our graph. The first one of which is the graph is a blank of a factor of 1/3. And since it's the factor of 1/3, that's referring to this 1/3 right here. And that means we're talking about whether or not it is a stretch or shrink. Now, If it's a fraction, we're going to have a vertical shrink, assuming the fraction is less than 1. Typically, if we have a factor that is going to stretch it, we're usually just doing a whole number rather than a fraction. But if it's a fraction, we're going to have a vertical shrink, as long as that fraction is smaller than 1, meaning the denominator is bigger than the numerator, or the bottom is bigger than the top. Now, the next part is reflection in the what? All of the reflections we have are in the x-axis. But that refers to it flipping from opening up, like this, to opening down, as we can see here. And then we have to look at our translations. And we need to look at them in terms of whether or not they're moving up and down, left or right. And you should be able to read this directly off the graph. We move 3 units to the left. So I put that in. And then if we look over here, and we move 2 units down. And we can tell we move 2 units down because each of these boxes represents 2 units. So you will have to pay attention to the scale on the graph. So we 3 units left, 2 units down. You also could have gotten the 3 units left, 2 units down from looking at the equation itself. In fact, it was not necessary to even look at the graph on this one because all of this information is actually included. All the information down here that we needed is actually included in our equation. And again, you will still have a pool of answers to choose from, and make sure that you choose the units for the translations, the X or Y axis for the reflection, although it should always be the X axis because we didn't do any Y axis reflections, and the graph, whether or not it's a vertical stretch or vertical shrink. All right, good luck on the final.